Let's take a look at these function questions. Question 4 reads, given that f of x is equal to minus 2 over x plus 4, determine the equation of the horizontal asymptote of f. Now, if you are given a hyperbola, and this is a hyperbola, minus 2 over x plus 4, this last value here, that's your horizontal asymptote. It's a y equal asymptote. This one right here, that's your vertical asymptote. Okay? That is your x equals asymptote. So they want to know what is our horizontal asymptote. The horizontal asymptote is going to be 4.1.1 y equals 4. Question 4.1.2, determine the coordinates of the x-intercept. Now, whenever you are solving for any function, if you want to solve for the x-intercept, you make y 0. So my equation is 0 is equal to minus 2 over x plus 4. Now, what I want to do here is I want to multiply this whole thing by x, because I have x in the denominator here, and so I want to get rid of that. So I'm going to get 0 times x is 0. That's equal to minus 2 over x times x. The x's would cancel, so it would look something like this. So minus 2 over x times x, and then plus 4 times x. Now here, this x would cancel with this. So we're going to be left with 0 equals minus 2 plus 4x. Now you can take the minus 2 across. 2 is equal to 4x. Now divide both sides by 4. That 4 cancels that 4. 2 divided by 4 is half. So half is equal to x. But be careful, the question asked for a coordinate, and so coordinates should always be x first and then y. Let's move on to question 4.1.3. Sketch the graph. So first thing we'll do is we will draw in our x-axis, our y-axis. Now we know a horizontal asymptote is at 4. So let's put 4 here and dotted line to represent that asymptote. We also know that the x-intercept is half, so maybe half is somewhere here. And now we just need to draw in the graph. Now it's important to remember the following, that whenever you have a hyperbola, if the numerator is negative like it is now, then the hyperbola is going to have a curve in this quadrant and this quadrant. But if the hyperbola, if the numerator is positive, so if the a value is positive, then the curve is going to be in this quadrant and in this quadrant. Now, since it's negative, we're going to be drawing it in these quadrants here. So one curve will go here. Remember, it cannot cross the asymptote. And one curve going through here, cutting that x-intercept like this. Now moving on to question 4.1.3. Determine the equation of g if g is formed by shifting the graph 7 units down. Okay, so for any shift, for a shift like this, we're going to start off by saying g of x is equal to f of x. So that's what they tell us. It is the graph of f, but it shifted 7 units down. So minus 7, because we're shifting it down. So g of x is equal to, well, we know what f of x is. F of x is minus 2 over x plus 4 and then the minus 7. Now all we need to do is simplify those. So now g of x is equal to minus 2 over x minus 3. And that's it. Let's take a look at the next one, 4.2. The graph of h of x is equal to 2 to the power of x minus 2, and it's sketched below. Determine the coordinates of A. Now, A is a y-intercept. So 4.2.1, to solve for a y-intercept, we make x 0. So the equation is y is equal to 2 to the power x minus 2. Now, if we make x 0, y is equal to 2 to the power of 0 minus 2. 2 to the power of 0 is 1. So y is equal to 1 minus 2. Y is equal to negative 1. Since they want a coordinate, A is therefore going to be 0 and minus 1. Let's input that right there. Okay. 4.2.2, write down the range of h. Now, range refers to y values that would be applicable for this function. Now, we can see quite clearly that this function is going up right here, and it's going to go all the way up to positive infinity. However, the graph going down is tapering off and moving along in this direction. It's not going to cross this line right here. That line is known as an asymptote. And we can get the asymptote from the equation itself. This last value right here, that negative 2, that is the asymptote. The graph is not going to cross this point, minus 2. So to answer the question, what values would be applicable for this function, what range would be applicable, the y values are going to be from negative 2 all the way up to infinity. So you can write it in a few ways. I'll show you a few ways. You can say y is an element from negative 2 to infinity. You could also write y is an element of real numbers, but y must be greater than negative 2. Okay, let's move on. Question 4.2.3. Determine the equation of J if J is formed by reflecting the graph about the y-axis. So whenever you are dealing with reflections, and in this case, you're reflecting on the y-axis, the thing you should do is you keep y and then change x. What do I mean by change x? Let me show you. This is our original equation. Remember, y is equal to 2 to the power of x minus 2. We're keeping y. We're not changing anything about y, but we are changing x. So now the new equation is going to be y is equal to 2. And instead of x, we're going to write minus x and then minus 2. That's it. This is our new equation. Okay, let's take a look at the last question. Question 5.1. Sketched below are the graphs of f of x equals ax squared plus q. So in other words, it's an unknown. We don't know what the function is. And the straight line g. G is parallel to the x-axis, and S40 is the x-intercept of f. The graph of f passes through points T, P, and R. All right. Question 5.1.1. Write down the coordinates of P. Okay. Now, here you look at it, it's 1 mark. So it can't be too detailed or too involved of a calculation. Maybe not even a calculation at all. So what we'll do here is we'll use the knowledge that we have about parabolas. And what do we know about parabolas? We know that parabolas are symmetrical around its turning point. So my turning point is right here, right? And there's symmetry, meaning that the distance from here to here is going to be the same distance from here to here. What is the distance from O to S? From O is my origin, so that's 0. S is 4. So the distance from here to here is 4. which means that this distance must also be 4. But since P lies on the negative x half of the Cartesian plane, P will be negative 4 and 0. Okay, so the coordinates of P, negative 4 and 0. Let's clear this up. All right. Now write down the coordinates of R. Same thing applies here. R, we're going to use symmetry to figure out what R is. R lies on this line G. And since G is a straight line, the Y value is going to remain the same. So R is going to be something and 3. Now, to figure out what the X value is going to be, let's look at the distance here. The distance from here to here is going to be the same as the distance from here to here. Now we can tell that from here to here is 2 units, meaning that the distance from here to here must also be 2 units. But like with P, since it's on the negative x side, it's going to be negative 2 and 3. So R is negative 2 and 3. Okay. Move on. Write down the equation of G. Now what is G? G is the straight line, right? Now don't be confused here. It's not going to be y equals mx plus c. Since it's a straight line, it's simply going to be y equals 3. Right? Straight line parallel to the x-axis, the equation is going to be y equals 3. Okay, let's move on. Determine the values for A and Q. Now you can see here that the marks, 4 marks, so there is going to be some calculations involved, though let's look at what we know. So they want to know what is the value for A and Q. A and Q, they're referring to the parabola. And what do we know about the parabola? Not much, but we know that this point right here is minus 4 and 0. Now, if you know the x-intercepts of a parabola, then you can work out the formula using a different format of the equation. Now, if you've been given the x-intercepts for a parabola, you can use this formula. Y is equal to A into x minus x1 and then x minus x2. x1 and x2 are the x-intercepts. Now, what are my x-intercepts? Let's remind ourselves here. One x-intercept is 4. The other x-intercept is minus 4. Let's substitute those in. So y is equal to A and then x minus 4 and then x minus 4. Right? The minus 4 is for this one. Let's simplify a bit just to neaten it up. Y is equal to A to x plus 4 and then x minus 4. Now remember, we want to solve for A and Q. Now don't worry that Q is not in this equation. You will see how Q naturally will appear at the end. But we can see that there's A. Now if we want to solve for A, we need to substitute a point in. And the point that we substitute must be a point that lies on the equation, or on the function rather. We know point R, we know point T. So whichever we substitute will still work. But I'm going to choose point T to substitute in. For point T, the x value was 3, the x value was 2, the y value was 3. So we're going to substitute this into our equation here. So 3 is equal to A, and then 2 plus 4, and then 2 minus 4. Let's simplify. 3 is equal to A into 6 times minus 2. 3 is equal to minus 12A. Divide both sides by minus 12. So minus a quarter is equal to A. We've got the A value. Now if we want to work out the full equation and get the Q value, we must substitute this A value into this equation right here. Let's do that. So y is equal to minus a quarter, and then x plus 4, x minus 4. This right here is difference of two squares. And we can simplify this as x squared minus 16. So the next line will be y is equal to minus a quarter and then x squared minus 16. Now we distribute the minus a quarter into the brackets. So y is equal to minus a quarter x squared plus 16 times a quarter is 4. And that's my equation. This here is my a value. This here is my q value. Right? And this q value, this one here, is actually the y-intercept. So right here at the top, that's 4. Okay, let's move on. If f of x is equal to k, determine the value of k, or values of k, for which f of x has no x-intercepts. All right, how can we work that out? So what they want to know is what kind of shift needs to take place such that this graph will no longer have any x-intercepts. So if we shift this graph downward like so, then the graph can look like this. And if we move the graph downward like that, you can see that it's not cutting the x-axis anymore. There are no x-intercepts. But how many units do we need to shift it down? Well, we look at our turning point for that. Our turning point represents the maximum value that the graph has at the top. So if we move it down more than that, then the graph will no longer have any x-intercepts. So we need to move it down more than 4 units. So 5.1.4, k must be greater than 4. Question 5.1.5. Determine the coordinates of f if f is the reflection of t about the x-axis. Okay, not a problem. So t is 2 and 3. Now, if you are reflecting about the x-axis, then you need to change y. So the new point f will still be 2, but the y value 3 will become minus 3. That's all. Now let's look at these next two questions. 5.1.6a. Using the graphs, determine for which values of x, f of x minus g of x is going to be greater than 0. How do we interpret this? So let's color code our graphs so it makes it a bit easier to follow. So for f of x, I'm going to use this yellow color. And then for g of x, I'm going to use this green color. Now, what does this question mean? So the question is asking me here, where is the graph of f of x, meaning the yellow graph? Where is it above the green graph? That's what it's asking. Where is the yellow graph above the green graph? Because if the yellow graph is above the green graph, then if you subtract them, you will get a positive value. So let's look at it. Where is the yellow graph above the green graph? The yellow graph is above the green graph between this point and this point. So what is this point? We worked it out earlier. That's minus 2. Minus 2 and 3, but they only want to know the x values. So the answer to this question is that x should be between minus 2 and 2. Okay, now let's move on to the last question. And this question is asking where is or what values for x will f of x times g of x give me a value that is less than or equal to 0, or rather a negative value. Now we think about multiplication and how do we get a negative value in multiplication. So to get a negative value in multiplication, so f of x times g of x is going to be less than or equal to 0. So either this must be positive and that must be negative, or that must be negative and that must be positive. Now let's look at our graph. G of x is this green line. This green line is not negative anywhere, right? Because its y value is always positive, right? It's in the positive y value. So this option right here is out because there is no value where that's negative. So this is out. So we need to look for where is f of x going to be negative. Where is f of x negative? Let's look at our graph. This yellow graph is negative below this point right here. You can see it's negative here, and below this point right here. So we know these coordinates. This is minus 4 and 0. So we can answer it. We can say that when x is less than negative 4, or when x is greater than 4, that's when the product is going to be negative. All right? So let's write it out. So when x is less than negative 4, well, in this case, it will be equal to, because there's an equal to sign there. So less than or equal to, or x is greater than or equal to 4. Okay? That's it. Thanks for watching. Hope you found this useful. I'll see you in the next video. Bye-bye.